Good morning, good afternoon, and good evening. Today we're going to be combining all of our different methods of factoring into a bunch of practice problems where we will be factoring polynomial expressions. It's important to remember our steps though. The first thing you always want to check for when you're factoring is to check for a GCF. Check for GCF, or a greatest common factor. If you could pull out a greatest common factor, that makes the factoring process that much easier then. After that, either if you have a GCF or if there's no GCF, step 2 would then be to use our Xbox method. To factor. It works every time. The only exception would be is if we see one of those difference of perfect squares or DOPs, in which case you could just jump straight to the end. Good luck, and here we go. For question 1, the first thing we'll check for is if we have a GCF. In this case, there's not anything in common between our three terms that we could pull out, so we're going to jump right into my Xbox method. Up top, my A times my C, even though I can't see it, there is a 1 in front of that A, or in front of that x squared term. So 1 times negative 30 gets me a negative 30. And then in the bottom of my Xbox, I'm going to put my B term, which is negative 13. So I need two numbers that multiply to negative 30 and add to negative 13. So you could plug this into your calculator to figure out, or you could just think about it, and you should come up with negative 15 and positive 2. And don't forget, these also are my terms that are going to get my x's, because this is really how we're breaking up that B term. So we're going to bring down our A term, so I've got my x squared. I'm splitting up that B term into my two numbers that I just came up with, my negative 15 and my positive 2. So that is my minus 15x, my plus 2x, and then I bring down my minus 30. From here, I can do my factor by grouping. So I'm going to group my first two terms, group my next two terms. And what I can pull out from these first two terms, it looks like I can pull out an x from both of them. The coefficient in front of this is just a 1, so there's no GCF with the number, so I'm just going to pull out an x. I'm going to have x. What's left inside is just going to be an x minus 15. For my second batch of numbers, it looks like here between the 2 and the 30, they both have a 2 that goes into both of them, so I'm going to be able to pull out a 2. So I'm going to have my plus 2 out front. When I take out my 2, I'm left with an x minus 15. This is perfect. It's exactly what we want to see because inside of my parentheses matches up. I've got an x minus 15 and x minus 15. And now we just need to write our final answer. So the fully factored version of this is just going to be take what's outside of my parentheses, my x and my plus 2. That's going to be my first bubble. Came from my x and my plus 2. And what I'm going to write second is just what we have in common. I have an x minus 15, so I'm going to write my x minus 15. And we have successfully factored our first question. For question number 2, we're going to start by doing the same exact process. First, let's see if we have a GCF. My numbers out front, my coefficients. I've got 4, negative 12, and a 5. So, unfortunately, we don't have anything we can pull out here. In terms of my variable, I have an x squared, an x, and then nothing. So there's really nothing I can pull out. So again, we've got no GCF. So we're going to jump into our Xbox method. Up top, I've got my A term, which is my 4, times my C term, which is my 5. So 4 times 5 gets me 20. And then down at the bottom, I'm going to have that negative 12 coming from my B term. So we need two numbers that multiply to 20 and add to give me negative 12. In this case, it's going to be negative 10 and negative 2. Negative 10 times negative 2 gets me that positive 20, but when we add them up, it does stay negative, and it becomes that negative 12. So we know how we're going to break this down. So now we can go about rewriting our problem over here. So we'll bring down our A term. We got 4 x squared. Then break up that B term using those two numbers we just came up with. This is what these are used for, right? So remember, the x goes with these because they're from my b term. I'm going to break it up and see my negative 10x, my minus 2x, and then lastly I'm going to bring down that c term, which is my plus 5. Now we can go ahead and factor by grouping. So I'm going to group these first ones, group my second ones, and let's see here. I've got a 4 and a 10. What goes into both of these is I can pull out a positive 2, or a 2. So I'm going to pull out a 2 over here. So I would divide both of these by 2. And then if I look, I've got my x squared and my x. I can actually pull an x out of both of these as well. So I'm also going to pull out an x and an x. So that's a 2x there. So out front's my 2x. And then inside, when I do my division, I'm going to have 2x minus 5. Looking at my second question, I've got a negative 2 here and a positive 5. So I really can't pull anything out in terms of these numbers. However, I don't like this negative sign here because I want my inside my parentheses to be positive. I want it to be a positive 2x and a minus 5. Here I've got a minus 2x and a plus 5. So really what I want to do is switch my sign. So anytime I want to switch my sign, hopefully you can see that we want to pull out a negative, or we want to pull out a negative 1. So I'm going to make that my GCF. Since there's nothing that I can really pull out for my numbers, and this is the only term that has an x, there's no x over here. So my GCF is just going to be a negative 1, just so we can switch the signs on these and make it look like our first set of parentheses. So I'm going to take out my negative 1, and I'm going to be left with that 2x plus, 2x minus 5, which is exactly what we wanted to see from the first one, 2x minus 5. Now I have my parentheses matching up, which is perfect. So my final answer is going to be 2x minus 1, and that just came from what's out front, my 2x, my minus 1, and then I've got what's in common. I've got my 2x minus 5. 2x minus 5. And we're good to go. For question number 3, you should already be seeing that this is just a factor by grouping, and we can just see what's in common right now. If I look at my parentheses, I have an x plus 2 here and an x plus 2 right here. So I do have my GCF in this case. My GCF just looks a little different. It's an x plus 2. So this looks like the end of my Xbox method. All I'm going to do is take what's out front, so my 5 and my plus x. That's going to be my first set of parentheses. And then secondly is what we have in common, and that's just my x plus 2. So I really just did x plus 2 from both of them, and that's fully factored. There's nothing else we could do there, so we can move on to number 4. For number 4, step 1 is we want to check for that GCF. For my first term, looking at the coefficients between 10 and negative 25, you should see that we can pull a 5 from both of these. In terms of my variables, they both have a w. The most that I could pull out is just one of them, so I'm going to pull out a w from both of these. My GCF comes out front, 5w. Inside of the parentheses, I'm left with 2 minus 5w. Is there any need to do an Xbox method in this case? No, there's not. So we've got our answer right there, fully factored. For question number 5, the first thing I notice when I'm looking at this is that there's 4 terms. There's not our usual 3. So the AC Xbox method is kind of tough. We do want to look for a GCF, but if we're looking at all of these, there's really nothing we could pull from every single term. So in this case, the 4 terms should give away that we're just going to jump right into factor by grouping. So that means I'm going to group my first 2 terms, and I'm going to group my second 2 terms. For my first 2 terms, what I can pull out here, between the 2 and the 10, I can pull out a 2. And then I have an x squared and an x. I can also pull out 1x there. For my second 2 terms, I have a positive 3x and a negative 15. I can pull out that 3 from both of them, but I can't pull out an x, so I'm just going to leave it like that. So for my first one, I got my 2x out front, and then when I do my division, I'm left with an x minus 5. Hopefully we get the same for our second terms. So when I pull out that 3, I'm left with a positive 3 times, and I have an x minus 5 when I do my division. Perfect. My parentheses match up. We're good to go. So we could write our final answer. What's out front? We have the 2x plus 3. And then I have what's in common, my x minus 5. And that is my final answer. For number 6, again, it looks a little different. We don't have 3 terms, but let's still stick with that process. We're going to start by looking at a GCF. So between these two terms, I've got 25x squared, and I've got 100. I can't pull out any variable because this one doesn't have an x here, but 25 actually goes into both 25 and 100. So I'm going to pull out a 25. Start with step 1. Go look for that GCF. So my 25 is out front. And inside now, I'm going to be left with an x squared minus 4. You might think you're done at this point. However, if we look here, these are two special terms here because they're both perfect squares. X times x gets me x squared. 2 times 2 gets me 4. So in this case, I have a difference of perfect squares. This is one of those DOPS problems. So we can continue factoring here to finish this off. The 25 we're just going to bring straight down, 25. Now, for the rest of my problem, I can break this up. The square root of my x squared is going to be x, so the x is going to lead off both of these terms, or both of these expressions. And then my 2 is the square root of 4, so I'm going to have that in there. And then with the DOPS, we know we need 1 positive and 1 negative. At this point, we're fully factored. There's nothing else for us to do here. We have our final answer, and therefore, we're done with this question. To finish this lesson, you're going to be trying a few problems on your own. I will help you out a little bit, though. For question number 7, I want you to look back at question number 1. It's going to be very similar. Question 8 is going to be along the same lines as question 3. So if you need a little help, make sure you're looking back at the questions we've already completed. Question 9 is like question 4. Question 10 is like question 5. Question 11 is like question 2. Question 12 is like question 1. And there's 2 13s down there. I'm going to let you guys try those on your own, but just know we are factoring. So you're using the same process. You're using the methods we've been practicing for the last few days. Good luck, and make sure this is completed for class tomorrow. Thank you.